stage of a beginner. So let's just run it and see if our prediction was right. So 5 and %2 gives us 0, right? Because 1, 0, 0, 1, 1, 0, they're all different. You must have a 1, 1 to get a 1. So we end up getting 0. 4 or 5 is 5 because 1 or 1, 0 or 0, we get 0. 0 or 1, we get a 1. Whenever anyone is 1, you get a 1. So it's 1, 0, 1. That's 5. 4 exclusive OR with 6. Whenever it's the same, we get a 0. So it's 0, 1, 0. So answer is 2. Okay, and you have a inverting, bit inverting. So first of all, 3. 3 is of the value 0, 1, 1. 0, 1, 1. When we invert it bit by bit, it becomes 1, 0, 0. But 1, 0, 0 is 4. So when we do that, we get a -4 because it's got to do with the bit representation. It's 1, 1, 1, 1, 1 all the way, not just 1, 0, not just 1, 0, 0, but it's actually 1, 1, 1, 1, 1, 1, 1, 1, 0, 0. However many ones you have, if you have 64-bit, then you have a lot of ones on the left-hand side. So because of that, that is a binary representation of negative sign. Too much to get into here, but just that it is correct. Okay. Now, the next thing is true and false. Of course, it's false because you only have true whenever it is true and true. Notice that we are using the and here. We are not using the bitwise ampersand because here is a logical and. That means the and the or and the not, they work on Boolean values, true, false. They don't work on integer values. Unlike some programming languages which are pretty tolerant, anything that is any integer that is non-zero is true, 0 is false. But here, Python is going to basically make it very explicitly known that whenever you're using and, you're trying to say my left side and my right side, they are logical comparisons that are either true or false. Don't give me any other integer or floating point number and expect me to somehow make some default guessing about them. That's, I think, is good because it enforces more discipline on what we are actually trying to do rather than a bit laissez-faire and depend on Python's rounding and typecasting and all that, which is a bit dangerous sometimes. Next, we have is and is not. This is a little bit, is and is not is more for complex object comparison. So for example here, we are going to ask, is this content equal to this content? All right. For string, we can actually just use the equal sign, the double equal sign to check. So we can also say, instead of saying car is automobile, we can say car equal to automobile or not. All right, then that is also possible. That's for string. But for complicated class objects and instances and opaque objects that we don't get to see the content inside, because sometimes we don't care. Sometimes we just don't have access to look at the contents inside. Sometimes it's too complicated for us to understand, so we don't want to look inside. For whatever reason, this complicated object, is it the same content as the other complicated object? And that is the is operator for us to ask Python to inspect. All right, see whether they are the same or not. And of course, we have a corresponding is not, right? So is apple a melon? But melon is non-citric fruit. So here we are just storing the content of the string so that it gives us a nice answer. Apple is not melon, right? And apple is not melon, that statement is true. So it gives us a true. Okay. Next, a very powerful operator, in and not in. In and not in. Notice the not is in front now. So because it spells better. So in is very powerful because it's like a search. We ask the question, true or false question. Is 5, the value 5, is it inside the list containing 3, 5, and 7? Answer is yes. So the answer is true. Then we ask, is the value 4 contained in the list 3, 5, and 7? Now this is like a search, right? Find me 4 in this space. Answer is it is not in, and so that's true. Yeah, okay. So likewise, we can always say is 9 in 99999 and minus 9? And the answer is false, right? Because it's not there. But we can ask the negated question. Is 9 not in this? If that is not the case, we add 9 into it. And that's true. You should add 9 into it. All right. So that's a short list of those operators that take in different values and produce logical outcome, true or false. Now, logical outcomes are important because they are used extensively in if, right? If expression which must come up with a logical outcome, true or false, then we branch accordingly. And likewise, we have while. While the logical outcome is true, continue with the loop. Once the logical outcome is false, exit from the loop. So all these are very powerful operators to give us combinations of logic that end up making our program very, very useful. Okay, finally, we have just a quick discussion on interesting expressions. Right. So first of all, we want to combine them to form very rich and powerful values that would model our universe, that would represent our problems, and give us a very powerful answer to help us in our work. That's definitely what we use programs for. So sometimes we may encounter the need to do interesting calculations. Let me just finish up this part of the editing first to make sure that it looks nice. Okay, so here we want to print out S, we want to print out G, and we want to print out H. Okay, all right, so let's just print out and see that we were up to here, right? So these are new. So 5 plus 3 times 4.2 divided by 3. Now, fortunately, Python is very tolerant and understanding about mixing integer with floating point. So it's not going to complain and say, no, you have to change 3 to float first before you can continue and so on. So fortunately, we do get very beautiful answer very easily without much of trouble. Then we have, what is it? Assigning S. So we can plus strings together. Normally, that would be an abuse of the plus operator because while you can mix integer plus float, float plus integer, float plus float, int plus int, what is the meaning of string plus string? All right, that is not super clear, but we need that a lot of times. We need to concatenate, join up the strings in many cases because text is what changes our mind, right? When you read email, that's text. So if we append the words between two sentences, we want a very easy way to express that. And of course, plus is a very nice operator if we can make it work, and Python makes it work. So for example, we say the string me plus space and space you. So it becomes me and you. And that's okay, legit. So what is S? S is me and you. Then we have this weird expression. We may want to say ha ha ha, right? If you're typing email or emoticons or whatnot, you might say ha ha. Now, if you want to say 5 times, then one way is to type it out. Or you can say this string I want to repeat 5 times. Now, this is really a luxury. We actually shouldn't have this. This is an abuse of the times operator. But actually, we do have occasion to have repeated strings concatenated with each other many times, right? So this is actually useful, although using times 5 is quite an abuse of the times because we should have number times number. Here, it actually is quite making sense because we want 5 copies of the ha. So we have ha 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 here. And smiley, if you want to have 5 copies, you should be able to do that. And notice that it is commutative as well. So I can have the string times 5 to have 5 copies of the string, or 5 times the string. Right? So if you want a smiley with a space repeated 100 times, you can just do that, and it will fill up your screen with a lot of smileys. So then, thanks to that, we are able to generate repeated strings very easily. So one perhaps more practical use of such a string, rather than as a curiosity, is to print a divider line on the screen. So oftentimes I may want to print a line and say, look, after here, or maybe I should do it in a program to show you. So after here, right, rather than print everything, all the outputs, and then suddenly jump to another discussion, I want to print a divider line here. You see what I'm trying to say? So when I print a divider line and I print it and I run it, the divider line is going to clearly demarcate the earlier outcomes with the new discussion. So that's nice. But because now we know how to use the times operator, we can just, very easily just do a dash times 30 and it will just produce the same result as well. All right. We can even design it a little bit and do a dash dot colon equal and repeat that string 30 times, and you will have this very nice long designer style demarcation line being drawn on the screen. Yep, okay, so that's all I have for you in this topic. Thanks for listening in. I'll see you in the next set of videos.